We are going to see how do we do more examples about drawing these continuous random variable PDFs, and also how can you use the graph you've drawn or a sketch to find the area and then find the value of k of the given constant here. So let us start with this number. Say when you sketch, you first get the points at these extreme ends. You get this in this function, then this in this function. This is going to be the same in this function. So here, not first line. Then you also substitute for this function there. So now solution that you can sketch. But I told you that the moment is that this is having a positive gradient, means that it's going to increase. This one is having a negative gradient. It's a line. These two are lines. Why? Because they have power 1. So meaning this one is a line which is increasing, this one is a decreasing line. So that one can give you a picture. So the first we have our f of x equaling to 2kx. This one at the interval 0 less or equal to x less or equal to 1. So the first test when x is 0. When x is 0, we are putting in this function f of 0 will be 2k into 0, which will be at 0. So the point there is going to be 0, 0. Then you test for also this one. So when x is 1, you have f of 1 equal to 2k into 1, which will be 2k. So this will be 1, 2k. Then this one in this function is going to give you the same value. Just now test for this. So our f of x equal to k into 3 minus x. Then our f of, for this one is 4, 1 less x less or equal to 2. This one is going to, this one here, since it's continuous, both in this and then this function is continuous here, and this one means that this one is going to give you the same value this one you got. So now don't waste time substituting this one, come directly to this one here. So when x is 2, why am I using a different function? Because now I'm on a different interval. That's why I'm using now this function. So I'll be adding my f of 2 as k into 3 minus 2, which will be a k. So here I have 2, k as my, then you get your ruler, then you come and you draw that sketch there. It's just a sketch, you don't take a lot of on it. So now you see I have 0, 1, 2. So this is my 0, then you have here my 1, and then call this my 2. This is x. I'm sketching against against x, f of x. So now you put the first was 0, 0, meaning it's going to be here. Then the next is this point 1, 2k. So if this is my k, then the next is going to be 2k. And I'll be adding 3k somewhere there. So now I have 1, 2k. 1, 2k. This is the one there. 1, 2k. Then I also have 2, then k. 2, then k. It is going to be somewhere there. Then after you come and you join this. So join like that. So you name them. So that this one is not part, but I'm just using right at this end in where just. So now this one, you name this function. This was our f of x equaling to 2k x. Then this one is our f of x equaling to k into 3 minus x. So now they want us and hence find the area. How do we get the area here? So start, if I divide this into 2, like this, and I say this is area of a triangle, then this is going to be a trapezium. So start, this one is area A1, and this one is area A2. The one need to get and hence find k. What you do after sketching, you get the area of this, then the area of this, but you know that the whole area, because this is a continuous random variable, the whole area should be a 1. You see that our area is always a 1. So if I get a1 plus a2, I should get a 1. Now this one is a triangle. So I'll get a half BH. Then this area is for a trapezium. So instead I'm going to get a half H into A plus B equaling to 1. So that sounds good. A half times the base from here up to here, that is 1. Then the height from here up to here, is that we have 2k. Then plus a half times the height. Our height now for the trapezium, our height is from here up to here. This is the height of the trapezium, so 1 into now A. This is our A, which is k. Then plus B, this is our B from here up to here, which is 2k. All of this will be giving me a 1. So here I have k. Then here I have plus, this will be 3k over 2 equaling to 1. And to simplify this, we have 5 over 2. So that here we have 5k over 2 equaling to 1, implying that our k is 2 over 5. After getting that, now you come and substitute here. So that we have our PDF without these constants. So when I put here 2, I'm going to be having now 4 over 5x on the interval. Because this 2 times the k, 2 times this, that's why we get before then the x. Then here I have 2 over 5 into 3 minus x on the interval 1 less x less or equal to 2. Then 0 and where. Always make sure that this one is summing all of that. When you come now to find, now part B, they want us to find this probability. The probability when x is greater than 0.5 given when x is less than 2. What happens here? Here we say, remember, when we have probability of A given B, the same as probability of A intersection B over probability of B. So start, this one is going to be our A, this one is going to be our B. So my probability there of x 0.5, x less than 2 is going to be probability of x, their intersection, then over probability of x less than 2. Now, how do we get the intersection? It's now our intersection, we have a 2, we have a 2 there, then we have a 0, then we have a 1 there. That's what we have. So it's like we want the intersection above 0, this is our 0.5. So above 0.5, these are the values. Then below 2, this one is telling us below 2. Below 2, these are empty. Because anyway, we put them because we are continuous from here up to here at 0. So we are the intersection. Their intersection of these two. From here up to here, then from there up to there. The intersection is that this is where they are going to intersect. That's the way these two are intersecting. Because we say in continuous signs and so on that. So it means that now this one, our probability of x greater than 0.5 to where all the intersect now, this is the same as probability above 0.5 but below a 2. In simple terms, that's it. Then you also count and get this probability, then after we divide it. So this will be now integral from 0.5. 0.5 is in this. So 0.5 up to 1. Then our function, which is 4 over 5x dx, then plus from now 1 to 2 of 2 over 5, 3 minus x, and then dx. So there, we put in our value. So when I integrate that, we get, when I integrate this, I get, okay, 4 over 5, then you will skip steps, x squared over 2 from 0.5, 1, then plus the whole of this. After integrating it, we get 2 over 5 into happens if you substitute this 3 will cancel. So I have 2 over 5 into, when I square 1, I get 1. When I square 0.5, I get a quarter. Then plus 2 over 5 into, when you put in a 3 here, when I put in a 3, this will be 6. So here when I put in a 2, I have 6, then minus 2 squared, this will be 4 over 2. So this one is I get 2. Then minus, when I put in a 1, when you put in a 1, we are going to get, okay, we have 3. So here we have 3, then minus 1 over 2, which will give us 6 minus 1, which is 5 over 2. Then minus 5 over 2. And this will give us, this one is going to give us 3 quarters. This one is going to be 3 quarters. So this 3 quarters we get, and this we get 6 over 20. Then plus, what happens here? So the value we are going to get here is a negative 1 over 4. Negative 1 over 4. When I simplify this, 4 minus 5 over 2. This will be 4 minus 5 over 2. When I multiply, I have now minus 2 over 10, which we can able to simplify this 3 over 10, which will be 1 over 10. So when I come now to the integral of probability of x less than 2, now this will be from 2 to 1, then our 2 over 5 into 3 minus x dx. Then plus from 0 to 1 or 4 over 5x dx. This one, when we interpret this, we have seen that we are getting, all of this is leaving us. All of this, okay. After interpreting, we shall get the whole of, because the whole of this is this, carrying it here and then here, we shall get negative 2 over 5. The whole of this will give us negative 2 over 5. So, negative 2 over 5, then plus, what happens here? We get 4 over 5 x squared over 2 from 0 to 1. Once this 2, you have negative 2 over 5, root over 5, and this is over 10, not 5, over 10. Negative 2 over 10, then plus, into bracket, this is 4 over 5, into bracket. When you put in the 1, you get a half. When you put in this 0, you get 0. So that is how when you put in, and when you put in, you get a half. It is just a half. When you put there, you get a half. When you put in the 0, you get a 0. So it's that this one. This is the same as negative 1 over 5. Then plus, this will give us 2 over 5, which will be 1 over 5. So thereafter, you come and now take our probability here. We say that our probability of x greater than 0.5 given probability less than 2 will be now. The whole of this one which was up, this one, we have got 1 over 10, then divided by 1 over 5. This is 0.1 divided by 0. I think this one is going to be 0.2. 0.2, which will be a half, and that will be the answer. So that's how we handle given probabilities. I wish you well.